Hello everybody, welcome to another lesson by me, Miss Pythagoras. After studying a variety of previous exam papers, I discovered various ways in which they try to catch you out. In this lesson, I will discuss the different scenarios on how to find the equation of a cubic function. Now this is lesson 6 of 6 on sketching a cubic function. Remember, you can also visit my website onlinemaths.co.za and find all the chapters in the grade 11 and 12 syllabi. The link is in the comments below. If you haven't subscribed yet, please do that now. Back to the maths. So, in this lesson, I'm going to explain different scenarios on how to find the equation of a cubic function and bonus typical exam type questions. Let's start. The first example. For a certain function f, the first derivative is given as the derivative of f in terms of x is equal to 3x squared plus 8x minus 3. It is further given that f of x equals ax cubed plus bx squared plus cx plus d, that's the original function, and f of 0 is equal to negative 18. Determine the equation of f. Now, first of all, let's zoom in on this. This is a very important piece of information. F of 0 equals negative 18. That means that's the y-intercept since x is equal to 0. Therefore, we can already start by saying that d is negative 18. In goes d negative 18. Now, what is given is that this one is a derivative. Then, let's take this function of ours and find the derivative. When we find the derivative there, we end with 3ax squared plus 2bx plus c. Then, also given was this other derivative, 3x squared plus 8x minus 3. So we sit with a situation where we have two derivative functions there. And then what we can do is we can equate 3ax squared to 3x squared. And then x squared and x squared will cancel. 3a equals 3 and a's value is 1. In the next step, what we can do is we can equate the two x terms by saying 2bx is equal to 8x. X and x will cancel. 2b is equal to 8. Therefore, b is 4. And in the last step, c is equal to negative 3. Therefore, the equation of f will be, in a's place, we substitute 1. In b's place, we substitute 4. And in c's place, we substitute negative 3. And then we already know that d's value is negative 18. And there's your equation. Now let's look at this example. The equation of the curve is given as f of x is 3x cubed plus bx squared plus cx minus 27, where b and c are constants. The derivative of f of 1 is equal to 12, and the second derivative 1 equals negative 24. Show that f of x is 3x cubed minus 21x squared plus 45x minus 27. Can you see in this example, the first derivative was given and the second derivative was given. We haven't seen one of these before. Now, where to start? We start with the equation and then we find the first derivative. So the first derivative will be 9x squared plus 2bx plus c. Then the point was given and the x value is 1 and the y value is 12. Therefore, in x's place, we substitute 1, 9, 1 squared plus 2b times 1 plus c. And then we can also equate to 12. So we are substituting the point into the equation. Therefore, 1 squared is just 1 times 9 is 9. And then let the 9 walk across. 12 minus 9 is 3 equals 2b plus c. And we call that one equation number 1. Then we will work with the second derivative. So first of all, what I did here was I worked out the first derivative. There, you see it there. And now, since the second derivative is given, I'm also going to find the second derivative. And it becomes 18x plus 2b. And then the second derivative, there's a point, 1, negative 24. So in x's place, I will substitute 1, 18 times 1 plus 2b, but the second derivative is equal to negative 24. So there I will substitute negative 24 and I will solve b. Therefore, negative 24 equals 18 plus 2b. Let the 18 walk across, it becomes negative. Negative 42 plus 2 is equal to 2b. Divide away the b, and b's value is negative 21. Then let's substitute b is negative 21 into number 1. In other words there. So I end with 3 equals 2 times negative 21 plus c. 2 times negative 21 is negative 42 plus c, and let c walk across, therefore c's value is 45. And the equation is indeed f of x equals 3x cubed minus 21x squared plus 45x minus 27. The graph of y is equal to ax cubed plus bx squared plus c has a local maximum at negative 1, negative 1 and a local minimum at 0, negative 2. Determine the values of a, b and c. Now first of all, let's zoom in on this point, 0, negative 2. Although they say that it's a local minimum, we also know that that point is a y-intercept since x is equal to 0. Therefore, in c's place, we can substitute negative 2. Then, let's zoom in on this other point, the local maximum, negative 1, negative 1. And now we will deal with that point as a turning point. So first of all, we will find the derivative equals 3ax squared plus 2bx, and we will equate to 0 since it's a turning point. And then in x's place, we will substitute negative 1. In x's place, in goes negative 1, everywhere where you see an x, and then that becomes 3a minus 2b equals 0, and we label that one number equation 1. Then we dealt with that point as the turning point. Now we will deal with it as a normal point. So into the original equation, in goes the point negative 1, negative 1. In y's place, substitute negative 1, and everywhere where there's an x, you substitute negative 1. And it becomes negative 1 equals negative a plus b minus 2. The 2 walked across, and negative 1 plus 2 is 1 equals negative a plus b, and I made b the subject of the formula, and I labeled the equation number 2. Now substitute number 2 into number 1. There's number 1. In number 2's place, everywhere where you see a b, you substitute 1 plus a. In goes the minus 2. 3a minus 2a is 0. 3a minus 2a is a minus 2 is 0, and a is equal to 2. Then, to find b, substitute a is equal to 2 into number 2, or 1. I chose 2. 1 plus a is equal to b. In a's place, substitute 2. 1 plus 2 is 3. and that's B's value, and we already know that C's value is -2. Let's look at an example where there's a tangent. So the tangent to the curve of g of x is equal to 2x cubed plus px squared plus qx minus 7 at x is equal to 1 has the equation y equals 5x minus 8. Show that 1, -3 is the point of contact of the tangent to the graph, and then find the values of p and q. So what we have in this situation is actually, there's your cubic function, and then there at the point 1, -3, you find a tangent. So first of all, we have to show that 1, -3 is the point of contact. So what we do, in x's place, we substitute 1, and we end with y is equal to -3. The corresponding y value is -3, so that is enough proof to show that that is indeed the point of contact. Then, now we will start with the sum. So there's your equation, and we will find the first derivative, and we end with 6x squared plus 2px plus q. Then we everything is happening at x is equal to 1, so in x's place I substitute 1. Then, please note, can you see I did not equate this gradient equation or derivative to 0, since this is not a turning point. What is happening is, remember, the derivative means the gradient of the tangent. So we have the tangent's equation. It's y is equal to 5x minus 8. So 5 is the gradient. And the derivative also means gradient of tangent. Therefore, on the left-hand side, we can equate to 5 equals 6 plus 2p plus q. Let 6 walk across. 5 minus 6 is -1, and I made q the subject of the formula, and I labeled it number 1. Now, let's deal with this point 1, -3 as just a normal point, so that we can have another equation to do simultaneous equations with. In x's place, x is -1, y is -3. So in y's place, -3, and everywhere where you see an x, you substitute 1. This becomes -3 is 2 plus p plus q minus 7. 2 minus 7 is -5. Let the -5 walk across. -3 plus 5 is p plus q. 2 is p plus q, and I made q the subject of the formula. Now, 2 minus p is q, that's equation number 2. I will equate the two equations since both of them are equal to q. And then I can say -1 minus 2p is equal to 2 minus p. Let's get p's on one side and numbers on the other side. -1, -2 is 2p minus p, -3 is p's value. Then substitute p into p's -3 in number 2. There's number 2. In p's place goes -3. 2 plus 3 is q, and q's value is 5. Thank you for watching. Remember, if you haven't subscribed yet, please do that now. There's more to come. This is Miss Pythagoras signing off. Till next time.